So we left off talking about the relationship between two variables, and the way we measure it is through the correlation coefficient. That correlation coefficient tells us a story, or the R value. It tells us whether the association is positive or negative. So an R value would be positive or it would be negative, depending upon the direction. Okay. If it's close to 1 and it's a value always between -1 and 1, if it's close to 1 or -1, then we see a stronger relationship. R equals 0 implies that we probably don't have a linear association, okay, or there's no association. And we don't care about the units, it's just a number that tells us how strong the relationship is. And we only use for linear associations with no outliers. So outliers cause problems for us. And R is what we call a statistic because it comes from sample data. And so in addition to looking at those values, those R values there, and you know what, we're not going to do it in this video, but I would go to this website here and take a look so you can look at R values and graphs. So you can look at a graph and then say, oh, what's the R value for that? Okay. And so where that takes us to in this section is to 12.3, which now we're going to actually not just see if there's an association. What we do is we try to actually find a mathematical model or an equation for this. And what we call that equation, and we're studying linear relationships, right? There's more advanced ways to do this, but we start off with linear relationships for this class. Line of best fit, you may have heard before. Least squares regression is the common term we use in this class, or general linear model. We use technology to get this. And so in order to get this, though, you need to start to think about relationships in the world, and we're interested in relationships. And again, you can read this paragraph, but people have claims about our world all the time, something we've been talking about in this class. And one of the questions is, again, is how do we know how if these claims are true, right? There's inherent in these claims are some associations or relationships between them. And we call those relationships, right, between these two variables, we call one of these variables a predictor variable versus an or explanatory variable, or you may have heard the term independent variable, okay, and response variable or dependent, right? And that's, in math, we just use X and Y's. In statistics, we name these variables because there's a relationship between them. One variable is a predictor, right? It predicts. It's a predictor variable, helps us predict the value of another variable. So keep that in mind as we're doing these equations. Don't get too lost into the equations, but really in the relationships. And if we had more time, we would explore this activity if we were in class, really thinking about explanatory and response variables. This is a typo here. This should say response variables, okay? For example, I'm thinking about what are the variables that cause success in this class. Success maybe is your grade, right? So it's quantitative, your average. And then what explanatory variables would explain that, right? And we could have some really interesting conversations around all these different variables and what explains that. But I want you to have that in mind as we go ahead and try to construct these least squares equations, lines of best fit, right? That's what we're going to be doing with a stat crunch. But again, like I said, we don't have full time, but look at these variables and really think about which ones would match up with these response variables, what explains these outcomes here. And that's what we're doing here. And so what's going to happen is when we find our least squares regression, right? Or again, we may say for short, just regression equation, regression line. But you have to recall that we're talking about this idea of y equals mx plus b. This is from algebra, okay? And again, I want to make sure I write this to emphasize, right? Many times you're going to see this term, least squares regression, okay? And this is the line of best fit, and you will see it in this form. So we're going to end up using StatCrunch, we'll do that in the next video, to calculate a line of best fit, or the least squares regression, or the regression line. And you'll see it in this way where we end up with a slope and y-intercept right? You may need to review that a little bit if this is like starting to say, I forgot all that stuff. You may need to do a quick review of y equals mx plus b. But in statistics, you'll see many times y hat equals a plus bx. A is the y-intercept, b is the slope. You may see it as b0 plus b1x, right? They all mean the same thing, just different variables. You see mx plus b in mathematics classes like algebra. And the hat above the y, right, is a symbol to means that the y value is a predicted y value, right? This hat symbol is very important in distinguishing between again, take a look at it here. It's a predicted value for y rather than the observed value. The hat symbol is important to distinguish between those two, right? You actually have a value in the world, and then we make a prediction. So you got to start to distinguish between those two. But again, we're going to be looking at equations of lines here.